Hello guys, my name is Mayur Naik. I'm studying in SVC Bangalore at IS department. So today's topic is DD path and test coverage metric. Before going to this topic, let us understand what is a path testing. Path testing is a software testing technique used to verify that all the possible execution paths through a program or systems are working correctly. It involves basically identifying all the possible paths through the code and creating test cases to access each path and executing the test and verifying result. Key aspects of path testing includes code coverage, branch testing, conditional coverage, error handling, and performance analysis. So in code coverage, we ensure all lines of code are executed at least once. At the branch testing, checking all the decision points work correctly or not. At conditional coverage, testing all the possible outcomes of conditional statements. Then we got error handling, verify errors, conditions and exception handling. Performance analysis, identifying inefficient or problematic paths. So path testing is crucial. So why is it crucial? So for finding logical errors, then improving code quality and ensuring robustness of software. So in path testing, here we can see that the program graph of there's a four structure programming constructs. So this is for if then else. This is a pattern or this is structure of if statement. Then we got case or switch. So there will be the structure of case and switch. Then we got pretest loop. So basically while loop. This is the structure, and for do while loop, that is the post test loop. So here is the structure. So this is what we'll be going through, and let us see the DD path. So DD path is a software testing. So this stands for decision to decision path. It's a concept used in path testing, which is a white box testing technique. Here are the key points. So the definition, that is a DD path is a path segment that starts at a decision node and ends at another decision node or at the exit node without passing through any other decision node. What is the purpose of DD path? So DD paths help in analyzing the logical complexity of program and ensure through testing of decision points. Then we got the components of DD. So that is decision node and exit node. So these are the components of DD path. So in decision nodes, points in code where the program flow can take different paths. So example we can take is that if statement switch cases are the two of the examples. So exit nodes, these points are the program or the module terminates. So these exit nodes, they come at the last. What is the usage of DD path? So usage is that the tester identifies and tests all the DD paths to ensure complete coverage of decision logic. What are the advantages of DD path? So DD path, they help in achieving better code coverage and identifying untested logic paths and useful for detecting logical errors and decision making flaws. Here we will be considering triangle problem in DD path. So first at the program triangle 2, so we have ABC. We take the integers, the three integers, that is ABC. Then there's an output given, that is ABC. So basically we can give any outputs. So you can consider like 3, 2, 3 or 3, 4, 5. So the input is ABC. So we'll be given the input, and at last we'll see the output, that is side A is A. So at A we'll be storing the values, and it's the same goes to B and C. So the values are stored at the small a, small b and small c. So once we have given the input for these three values, we check whether it is a triangle or not. So here we can see the Boolean function. Boolean function means basically true or false. So if A is smaller than B plus C, and we use the and B is smaller than A plus C and C is smaller than A plus B. So the if condition goes through all these statements. So if any of these statements are not matching, so this will be this will not be a triangle, that is false. If these are checking, if all these statements are true, so it will be going to the next statement. So if it's a triangle, we check whether A is equal to B and B is equal to C. So if these are true, so this is an equilateral triangle. So equilateral triangle are having all these sides are equal. Then it goes, if it's not an equilateral triangle, it goes to else if. So that's A is not equal to B and A is not equal to C and B is not equal to C. Then output is scaling, and there will be one more else statement which can be as isosceles triangle. So that's how we end the program. So in this diagram we can see 4, 5, 6, 7, 8, basically giving the inputs and the outputs. So at 9 we know that there's an if statement which is going through here, so it will have two conditions, 10 and 11. That is 10 will be true and 11 will be false, and they come to 12, which is triangle or not. And so once there are many if else statements, so that's how it is done. So then we have the DD path. So here we can see clearly that we consider 4, that is first, and case definition is 1. So 5 to 8 will be taking as A. So we'll combine all these numbers and we'll be represent it as A. Then we have 9 as B, then we have 10 as C, then 11 as D, and then we have 12 as E, 15 as I, then 16 J, 17 is K, 18 is L, 19 is M, then 21 is G. So it's so on, we'll be taking the values. So case of definition is the number of the numbers which will be taken. So 5 to 8. So 5 to 8, the difference is 5. So at last we'll have 23. So that's how we'll exit. So once we are done with DD path, we'll come to test coverage matrix. So definition: the test coverage matrix it is a device to measure the extent to which a set of test cases covers a program. The purpose of it is identifying untested parts of the code, then guide the test case development, assess the quality and completeness of the test suites, then help in meeting regulatory or contractual requirements. So in test coverage matrix, we'll be going through the EF measures coverage matrix, which is one of the most famous test coverage matrix. So here in this table, we can see that C0 is represented. So there's a metric here. So C0, CT, CTP, CZ, CD, CMCC. So all of these are the metrics which will be taken, and all these, each and every matrix are having their own description. So C0 means every statement. So the statement should be considered as C0. Then C1 is the DD path, every DD path which will be taken. Then C1P is every predicate to each outcome. Then we have C Z, that is C1 coverage plus loop coverage. CD is C1 coverage plus every dependent pair of DD path. So we have seen the DD path before, so that's how we link these both. Then we have CMMCC, there is multiple condition. Then CIK, every program path that contains up to K repetition of the loop. Usually, so we take usually K is equal to, so C stat, that is statistically significant fraction of paths. So, and at last we have C infinity, that is all possible execution paths. So first we see the statement testing. So program graphs allow statement fragments to be individual nodes. Miller's C naught metric is subsummed by G node metrics. Statement coverage is generally viewed as the bare minimum. If some testament can not be executed by the set of test cases, there is clearly a severe gap in the test coverage. DD path testing. When every DD path is transfers, each predicate outcome has been executed. This amount to traversing every edge in DD path graph program graph. Therefore, the C1 metric is exactly out C chain metric for if then and if then else statements. So both the true and the false branches are covered. For case statement, each clause is covered. Then we have complex loop coverage. So Miller's C of IK. So CIK means C of IK. So C of IK metric extends the loop coverage metric to include full paths from source to sink nodes that contains loops. Loop testing has been studied extensively and with good reasons. Loops are highly fault-prone portion of source code. Then we have concatenated loops are simply sequence of disjoint loops, while nested loops are such that one is contained inside another. Then we have the knotted loops. So complex loop coverage are having two of them, that is concatenated loop and knotted loop. So this cannot occur when it's possible to branch into the middle of the loop and these branches are internal to other loops. Then we have a multiple condition coverage, that is Miller's CMCC metric, and is the question of testing decision made by compound conditions. So we can take two possibility here. So is to investigate the different ways of each outcomes by making decision table. Compound condition, three simple condition will have 8 rules yielding 8 test cases. Another possibility is reprogram compound predicates into nested simple if then else logic, then will result in more DD paths to cover. Statistically significant coverage. This C static, so C to the static metric is awkward. What constitutes statistically significant set of full program paths. This refers to comfort level on the part of customer or it can be the user. All possible path coverage. The subscript in Miller's C infinity metric says it all. This can be enormous for programs with loops. This can make sense for programs without loops and also for programs for which loop testing reduces the program graphs to its condensation graph. So thank you for seeing my video.